Hey everyone, let's do another power problem. A driver notices that her 1100 kilogram car slows down from 91 kilometers per hour to 71 kilometers per hour in about 5.5 seconds on the level when it is in neutral. Approximately what power, watts and HP, is needed to keep the car traveling at a constant 81 kilometers per hour? Okay, so this problem seems a little bit strange when you first read it, or it might not, hopefully not, but if it does, you just have to draw a picture, think about this logically. So you've got a car traveling at 91 kilometers per hour and in neutral, so there's no braking, but there's no acceleration, just friction, slows down to about 71 kilometers per hour, right? Now, we want to know how much power is required to keep her going at a constant 81. Okay, so if she goes from 91 to 71, notice that the number right in the middle of those two is 81. Okay, but right now she's traveling at 71, and it took her 5.5 seconds to go from that first speed to this speed. So in other words, in order to keep it at a constant 81 in the middle, we have to accelerate back from 71 to 91. It's got to accelerate fast back up to that speed within that same amount of time so that we average out to 81 kilometers per hour. Okay, so that's the idea here. Now, since we're looking for power, just like we saw in video 115, power is always equal to the change in energy or the change in time. Here we're dealing with change in kinetic energy. So we're going to replace that with delta EK over delta T. And delta EK, as you probably guessed, we're going to write 1/2 mv2 squared minus 1/2 mv1 squared divided by delta T. So now the masses, the speeds, everything we can plug in. We have the time as well. So let's factor out actually 1/2 mass. So 1/2 times 1100 kilograms, V2 squared minus V1 squared divided by delta T. It takes 5.5 seconds to slow down, so we want to use another 5.5 seconds to speed up so we get that 81 kilometers per hour. Okay, so the reason I left empty brackets for V2 and V1 is because we're given the values in kilometers per hour. We have to express it in meters per second. Okay, so now remember, the scenario is not now that we're going from 91 to 71. We're at 71. We're trying to get back up to 91. So in other words, V2 is going to be 91 and V1 is going to be 71 this time, right? Because we're now using this path to go back. Okay, so let's do our conversion down here. So if you saw video 115, I explained again how you do the conversion. If you haven't seen it or you don't know how to convert between kilometers per hour to meters per second logically, please check out video 115 and then come back to this one. I'm just going to go ahead and use a shortcut, I guess. 91 kilometers per hour divided by 3.6 equals 25.3 meters per second. That's the conversion. If you divide kilometers per hour by 3.6, you'll get meters per second. And the same for V1. V1 is 71 kilometers per hour. If you divide by 3.6, you'll get 19.7 meters per second. So there are our speeds. So V2, 25.3 meters per second, that's getting squared, and then the 19.7 meters per second squared, that goes there. And when you plug this entire expression in your calculator, you are going to get, you're going to get 2.5 times 10 to the 4 watts. Okay, so there is my power in watts. Now this question also specifically asks us to put in horsepower. We did horsepower back in video 115. We saw that 1 mechanical horsepower is about 745.7 watts. So 1 HP is this. So in order to convert watts to horsepower, we just divide those two numbers. Okay, so we're going to do 2.5 times 10 to the 4 watts divided by 745.7 watts per horsepower. So if you divide those two numbers together, you're going to have approximately 34 horsepower, which is also very low. All right, guys, if you enjoyed the video, please smash that like button and subscribe to Physics in the Flesh if you have any questions or if you want to keep seeing these videos that I post every weekday at 12 noon. All right, guys, enjoy your day, and I will catch you in the next video, 117, Power 3, to be posted tomorrow at 12 noon. Hey guys, that's it for this episode. If you enjoyed it, be sure to check out some of my most recent videos posted over there on the right, which you can click on your screen right now and watch. Other than that, guys, I hope you enjoy the rest of your day, and I will catch you in the next video. Is the end screen too long this time? Wait, you're still recording? No! Oh. Gotta move that chair out of the way next time.